Welcome back. Derivatives of trig functions. So you end up with like, where do these come from? That's what this slide is about. You want the derivative of the sine x, they plug it into our friendly definition of the derivative, which you remember as being f of x plus h minus f of x all over h as h approaches 0. And that is what they did here. They just, instead of for f of x, they use sine. And so what you have to do is you got to simplify this sine of x plus h with the sum formulas, which we learned last year. And I'm sure I did not make you memorize because I was like, you're just going to look those up next year or whenever you need them again. And you actually don't even need them at all here because it's done. This is a thing, and then you simplify and you factor, and you end up with all of this. And it turns out that this whole thing ends up being equal to 1. Like this is 1 as h approaches 0, and this is 0 as h approaches 0. So you end up with 1 minus 0. So you end up with just the derivative of sine x equals cosine x. And there's like something about that makes me happy to know that the derivative of sine is cosine. It's just it's like neat and tidy, and it fits in well with my idea that sine and cosine are closely related. So that's the derivative of sine. Derivative of sine x is cosine x. Boom. We could do this, and by this I mean make this cosine x plus h minus cosine x, and then use a cosine sum formula and blah, blah, blah. We're not going to do that. Turns out if we do all that, the derivative of cosine ends up being negative sine x. What do you know? Derivative of sine is cosine. Derivative of cosine, negative sine. So that's going to be, you're going to have to know those. You have to know and memorize all 6 of the basic trig function derivatives. Sine and cosine are just the first 2. So derivative of sine is cosine. I'm going to write all this down on one slide at some point, but just so you know why we're building up this like arsenal of derivative rules. Derivative of sine is cosine, derivative of cosine is negative sine. I'm going to show you guys quickly how to find the derivative of a tangent. We know the tangent of x is sine x over cosine x. So the derivative of tangent of x is the derivative of sine over cosine. And this is a quotient of 2 functions, and we have a quotient rule. Quotient rule says derivative of the top times the bottom, cosine x times sine x, minus the derivative of the bottom times the top. I did that wrong. Sorry. Derivative of the top times the bottom, they're both cosines, right? Cosine x times cosine x, and then we get derivative of the bottom, which is negative sine x, times top, which is just plain old sine x, all over the bottom squared. That's cosine of x squared. The bottom is often written like this, cosine squared x. We've seen that before. And the top, if we look, this is really cosine squared x. Minus minus gives me a plus sine squared x. On the bottom, we have cosine squared x. And hopefully, I'm praying, my fingers are literally crossed right now, that you remember that cosine squared plus sine squared is 1. We called that the Pythagorean identity last year. So that's 1 over cosine squared, which you may recognize as secant squared x. And so our final answer, the derivative of a tangent, is secant squared x. So these all come from the basic knowing that sine, the derivative of sine is cosine, derivative of cosine is negative sine. You can get all the other 4 just from those 2. So derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. Got to know those. I don't know any other way to say that. You got to know that those are what they are. Moving right along. Here's just some thoughts, just kind of some musings. I'm looking at this graph of sine x, and I'm thinking about the derivative as being the slope of the tangent line to this curve. I can look at this curve and be like, well, it looks like there's a 0 slope right here. Like it looks like there's a horizontal tangent. Like the slope of this curve right there is 0. That's like right about here. And then there's another 0 slope right there. That's like right here. There's another 0 slope right there. All right, a little bit shy of 8. And it turns out that the slope here is 1. And the slope here is -1. And the slope there is 1. And the slope there is -1. You can trust me on that, or you can question it, but I promise it's true. So if I'm plotting, what I'm doing right here is I'm plotting the slope of the graph of sine x. Like when x is 0, the slope of this graph, sine x, is 1. When x is like right in here, I'm not exactly sure what that is, but I'll tell you it's about 1.7. The slope is 0. Right here, it's like a little bit bigger than 3. Hint, hint. The slope is 1. Is this divided into 4? Yeah. So right here, a little bit bigger than 3. And then there's another positive 1 right here, a little bigger than 6. That's another hint. And so I get this kind of a curvy thing that looks like this. And if you think about what this is the graph of, this is the graph of the cosine. And like this point that was a little bit bigger than 3 was pi, like pi radians. And this point here that's a little bit bigger than 6 is 2 pi. And the cosine of pi is -1, and that's where that is. And the cosine of 2 pi is 1, and that's where that is. So like these graphs look very similar, except this one's like shifted. If you shift the graph up here to the right, or to the left, you shift all these points to the left, you get this graph. So there's some connection between the sine and cosine graph as far as the slopes of the tangents to this curve are concerned. It makes sense. Derivative of the secant. Oh, I know I did this one. I'm going to ask you guys to do the other ones on your own. So I'm going to do the secant so you guys can see what like the trick is here. Trick is here is remember that the secant is 1 over the cosine. And this is like a quotient of sorts. It's really cosine x to -1, but it's a quotient of sorts where the top function is 1 and the bottom function is cosine x. So we can use a quotient rule. Quotient rule says this derivative is the derivative of the top times the bottom. Derivative of the top is 0, so I almost don't care what the bottom is, minus the derivative of the bottom, which is negative sine, times the top, which is 1, all over the bottom squared. That's cosine x, cosine squared x. So this goes away, the 0 times cosine. Negative sine is positive sine, so I get sine x over cosine squared x. And this is, by any reasonable approximation, the derivative of the secant. But I will tell you it's always written the way I'm about to write it. You can imagine splitting this up a little bit. I'm going to take 1 cosine and move it over to the side. And if you want to, like, pause the video and take a second to understand that these things are actually equal. Sine times 1 is sine, and cosine is cosine squared. And then you can write this one as, this is like the tangent. And this is 1 over cosine is the secant of x. And so this is always written in terms of these two functions. Now always remember that the cosine of secant x is secant x tangent x. Cosine of secant is secant tangent. So it's another one we can add to our little arsenal of things that we know about the derivatives of trig functions. The only ones we haven't done are cosecant and cotangent, and I'm leaving those for you guys to do in the classwork. It's like, those are like exercises for you. So those are our derivatives. I think the next slide, I'm going to write them all down just so we have them all as a in a one spot. And I'll write down the ones that I didn't derive on here, but I'm going to ask you guys to derive them anyways. The derivative of the sine of x is cosine of x. And the derivative of the secant of x is secant x tangent x. And the derivative of tangent x is secant squared x. Those are ones that we just found up there. We also found up there that the derivative of the cosine of x is negative sine of x. And these ones we haven't derived yet, but I'm going to tell you derivative of cosecant x is negative cosecant x cotangent x. And the derivative of the cotangent of x is negative cosecant squared x. From my way of thinking, there's a pretty clear pattern here between the functions sine, secant, tangent, and their co-functions, cosine, cosecant, cotangent. Like cosine goes to negative sine. So like I change this from the cosine to the sine and I make it negative. Then secant tangent becomes cosecant cotangent. And secant squared becomes negative cosecant squared. But like, to me, there's like a pretty clear pattern. Secant becomes cosecant, tangent becomes cotangent, secant becomes cosecant. Everything becomes negative, and then that's how you do it. And like, so you change them from their functions to their corresponding co-functions. You can just memorize them all if you want. It's fine. At some point, I ended up memorizing all these without even trying to. It's just you use them enough, you got to memorizing. But these are the derivatives of the basic 6 trig functions. I'm going to put a star on this page because I expect you to know these. And what I mean by that is like on a test or something, I'll be happy to put a problem where I ask you to find the derivative of the cosecant and expect that you're going to know what that is. So you could derive it every time, but it might be faster just to memorize it. So I think I have like 2 practice problems and then we're done. So it shouldn't be that tricky. Find the derivative of this function. I look at this and I say to myself, this is a product of 2 functions. It's a product of x squared and cosine x. When I have a product and I want to take a derivative, I use the product rule. Derivative of the first times the second, that would be 2x cosine x, plus the derivative of the second, that's minus sine x. I'm just going to change that to a minus. Minus, well, it's x squared sine x, because I multiplied by the first one too. Minus x squared sine x. In theory, you could factor an x out of these, but I wouldn't even bother. You're done. You've taken the derivative. You use the product rule because you're a smart, capable calculus student. We're good to go. And last but not least, again, all you can do with these is take derivatives and apply formulas. You've memorized the formulas or you haven't. If you have, good on you. If you haven't, you probably should. Find the derivative of this function. Okay. So again, I see it's a product. There's like this big polynomial thing here and the secant. So product rule says derivative of the first times the second. Derivative of the first is 8x cubed. Negative is going to be plus 4x to the negative 2 times the second one. Plus, I'll write it right here. Plus the derivative of the second one times the first. Derivative of secant is secant x tangent x. And then just times the first one as it stands, 2x to the 4th minus 4x to the negative 1. So again, you can factor a secant x out of this, but don't. It's like not worth your time. If you can do this, I know you know how to use the product rule. You know how to take trig derivatives. I know you know how to use the power rule. That's a lot of things that you know how to do. You've demonstrated there. This is not a course about algebra, so I'm not going to ask you to do as much as I might normally. So hope this was enlightening. Feel free to check that out on YouTube, to pause it, and if you want to like go back and look at things. And we'll see you in class.